In the previous video, I introduced the historical context, or part of the historical context behind complex numbers. And we arrived at the solution to the problem of two numbers that add together to make 10, but multiply together to make 40, had to be 5 plus or minus the square root of minus 15. And of course in this you're square rooting a negative number, which really doesn't make much sense to us, seeing as two numbers, whether they are, well, a number that multiplies by itself, whether it be positive or negative, will make a positive number. So we can't square root a negative number, surely. But if we use a little bit of our surd knowledge, then if I just look at the square root of minus 15, then that is the square root of 15 times minus 1. And I could have chosen any negative number here under the square root sign. Now, that would be the square root of 15 times the square root of minus 1. Now, when you get to this stage, you might be thinking, right, well, it's all stemming down to this problem. I can't make this problem disappear, this square root of minus 1. So it was, I believe, Raphael Bombelli who came up with then the notation that we're going to let the square root of minus 1 be written as I, the imaginary unit, I. So I is equal to the square root of minus 1. So we can now rewrite this as 5 plus or minus root 15I. Okay? And this is what is deemed as a complex number. A number that includes a real part, a bit that is real, and an imaginary part. Okay? So a complex number is of the form A plus BI, where A is real, well, is the real part, I should say, and B is the imaginary part. So B is the coefficient of the imaginary part, of the imaginary number I, and that we call it the imaginary part. So it's a number plus this extra bit that may or may not exist. And a whole mathematics has been built up around complex numbers. And there's a lot of things you can do with them, and they are incredibly useful. So let's look at some of the bits and pieces that we can do with this letter I. Okay, so first of all, if we just redefine I as being the square root of minus 1, okay, then there are certain things that we need to look out for. You could of course have I squared. Well, that would be the square root of minus 1 squared, so that would have to be just minus 1. Okay, and sometimes people like to define it this way. Then if I had I cubed, so if I cube I, I've got root I, square root of minus 1, sorry, times square root of minus 1 times square root of minus 1. So it's this multiplied by this. So that would be minus the square root of minus 1, so minus I. So I cubed is the same as minus I. I to the 4, I to the 4th power, is minus 1 times minus 1, so that would be 1. And then I to the 5 would be 1 times I, so I. And then I to the 7 would be I times I, so I squared, which is minus 1. Okay, so you can see that it's going to go round in a big loop. So I to the 8 is going to be minus I, and then I to the 9, okay, is going to be 1. Okay, so each time I'm multiplying by I, I minus 1 minus I1, I minus 1 minus I1, I minus 1 minus I1, and so on and so forth. Okay, so you need to be able to multiply I together, like that. And consequently, you need to be able to multiply and add complex numbers together. So let's say I've got two complex numbers. I've got 3 plus 2i, okay, there's my complex number, and I'm going to add on 5 minus 7i. Okay, so I'm adding two complex numbers together. So I can add the real parts together, the 3 and the 5, so that makes 8. And I can add the imaginary parts together, so 2 minus 7 is minus 5i. Okay, so that would be the sum of the two complex numbers. If you wanted to find the product, then we're going to have 3 times 5 is 15, 3 times minus 7i is minus 21i, 2i times 5 is 10i, and then you've got 2i times minus 7i, which makes minus 14i squared. Now, what have we got here? We've got 15 minus 21i plus 10i, so minus 11i, and then you've got minus 14 times I squared. Now, I squared was minus 1, so that's plus 14. So minus 14 times minus 1 is plus 14. So we have 29 minus 11i. So that is the answer to the product of the two complex numbers. So we can add them, we can multiply them, and these are just a few of the different things we can do with complex numbers. And we'll be looking at more of these bits and pieces in the coming videos.